All right, here we are on page 2 for practice assessment number 1, unit 3. We are now here at the bottom of page 2 looking at questions 11 and 12. So let's go ahead and zoom in here on question 11. It says water evaporates from a table that is at room temperature. So we've got some water, and that's our system here is water that's on the table. It is at room temperature, so we know that the temperature is just 2 bars. We're at room temperature, and it tells us that it's water, so we know that it's currently in the liquid phase. We've got liquid water at room temperature. It tells us that it evaporates. Now, there's no mention of a change in temperature, so we can assume then that our temperature is going to remain room temp. But it does say that it evaporates, and by evaporating, that means it's going to change into the phase account. Excuse me, it's going to change into, the phase account is going to change into a gas. Okay, so it's going to go from a liquid to a gas. Now, in order for the energy to go, you'll notice that we start off with 4 bars here at the beginning, and then it changes to 6 bars a little bit later. For that to take place, energy has to flow into the system. Okay, energy has to flow into the system, which would of course cool the surroundings, but the system would gain more energy. And then question number 12, cold water at 0 degrees Celsius changes to ice at 0 degrees Celsius. Well, in both of these, our temperature stays the same. It's cold, right? It's cold, so it's going to stay down here at 0. Okay, and so both situations, before and after, temperature stays the same. But it does say that we start off with water, which is 2 bars in the phase account, and then it changes to ice, solid ice, which is 1 bar in the phase account, and we only have 1 bar escaping the account. Now, one thing that's important to understand about this last one right here has to do with the energy going in, but the only place the energy is going is into our phase account. The temperature doesn't change. Okay, that's kind of an important distinction to understand. So